You know, I was digging through the source code of a modern large language model the other day, and it just felt like staring into this abyss.
Oh, I know that feeling. It's a black box.
Totally. You open up something like PyTorch, and it's just layer after layer of abstractions, C++ kernels, optimization tricks. It's just this opaque monolith.
Right. The actual math, the real thinking, is buried under thousands of files of boilerplate. They're built for speed, not for understanding.
Exactly. But what if you could just take a sledgehammer to all of that? No libraries, no dependencies, no import torch.
Just raw Python.
Just raw Python. And that's the whole premise of Andrej Karpathy's new project, Atomic GPT. He built a fully functional, generative, pre-trained transformer in about 200 lines of code.
And it's not a toy, it's a statement. Karpathy stripped away every single efficiency optimization just to reveal the bare metal algorithm. We're talking about a neural net where the only tools are like addition, multiplication, powers, logs.
The absolute basics. So let's unpack the engine here. To make this work without a library, he had to kind of reinvent the wheel, right? Specifically with that value class.
Precisely. Instead of these massive tensors you see in PyTorch, every single number is its own object.
Its own object.
Yeah. It stores its value, but crucially, it stores its history. It dynamically builds a computation graph as it runs.
I love that. It's like every number has a little receipt of how it was made. So when it's time to learn to do backpropagation,
It just reads the receipts in reverse.
it just reads the receipts.
That's the perfect analogy.
Yeah.
It recursively applies the chain rule from the output all the way back to the input. You can actually read the calculus in plain English code. It just demystifies the whole thing.
Speaking of demystifying, let's talk architecture. It's a simplified GPT-2, but I noticed some really specific choices he made. For instance, swapping the standard GLU activation for something called squared ReLU.
Oh, that's a brilliant trade-off. Standard GLU, which is what, GPT-3 and Llama use, it's computationally expensive to implement from scratch.
Right.
Squared ReLU gives you a very similar nonlinear curve
Yeah.
that you need for learning complex patterns, but the math is just x times x.
So it's an approximation that costs almost nothing. Simple and sophisticated.
Mm.
He also switched to RMSNorm instead of layer norm.
Yeah, RMSNorm is generally more stable for training, which is critical when you don't have a whole team tweaking hyperparameters. And look at the attention mechanism. He's manually managing the KV cache.
Something that's usually totally hidden from us. That's the model's memory, right?
Exactly. Storing past keys and values so we don't have to reread everything constantly. Seeing it implemented in a simple loop really drives home how attention actually works.
Now, this is obviously a masterpiece for education, but let's be real. You probably shouldn't be running your business on 200 lines of raw Python.
Oh, definitely not. Efficiency exists for a reason.
For sure. If you are actually looking to scale or automate or integrate agents into a real workflow, you need industrial-grade tools. And that's where our friends at Embersilk come in. Whether you need help figuring out where agents can make the most impact, or you need full-stack software development for your AI projects, they are the pros.
Absolutely. You should check them out at embersilk.com if you want to move from this kind of theory into actual production.
Back to the code. The thing that really blew my mind was that this isn't just for inference. The 200 lines include the entire training loop.
He wrote the Atom Optimizer from scratch.
From scratch.
That might be the most impressive part. Atom tracks momentum and variance, the first and second moments of the gradients. It's complex, and Karpathy just implemented that math manually.
The full life cycle. And he pointed out that the whole thing fits visually in 3 columns on a monitor. Column 1, autograd, to the GPT model. 3, training.
And that visual is so key. It turns this ghost in the machine into like a spreadsheet.
Yeah.
It proves that AI isn't some kind of magic. It's just a sequence of atomic math operations.
It totally changes your perspective. You realize the difference between this 200-line script and say, GPT-4 isn't magic, it's just scale.
And that leads to a really fascinating thought. If the seed of general intelligence can be written down on a single page using high school math, maybe the complexity of consciousness isn't in the rules themselves, but just in the sheer magnitude of the connections. Maybe the universe is simpler than we think.
That is a beautiful thought to chew on. If you want to see that beauty for yourself, go check out the code. And if you enjoyed this deep dive, please subscribe to Intellectually Curious.
And hey, leave us a 5-star review if you can. It really does help us spread the joy of learning.
Thanks for tuning in. Stay curious, and we'll see you next time.